Welcome back. This is Mr. Greenstein's Geometry. We're in Chapter 10 and we're talking about Section 3. This is specifically using chords. So there's a couple theorems that we need to talk about. The first one is the congruence corresponding chords theorem. So it says that in a circle, two minor arcs are congruent if and only if the corresponding chords are congruent. So the arc here, AB, is congruent to CD because the chords AB and CD are congruent. The next one is the perpendicular chord bisector theorem, and this is really important. If a diameter of a circle is perpendicular to a chord, so here's my diameter, EG, and it's perpendicular to this chord FD, then the diameter bisects the chord into two parts here, and it's perpendicular to that chord. So this is a diameter and a chord, and if it's perpendicular, then it bisects it, and it bisects the arc also. FG is the same as GD. The next one is the perpendicular chord bisector converse. So if one chord of a circle is a perpendicular bisector of another chord, so we just have a chord here, SQ, and it's the perpendicular bisector of a chord TR, then the first chord, which is SQ, is a diameter, and it goes through the center of the circle. Very important theorems, especially the second one and the third one. So in solving these problems, solving for the measure of FG, the measure of FG, if you look here, we have a chord, and here's another chord, and I have congruent circles because they have the same radii. So that means that the angle here, J to K, is going to be the same as the arc angle G to F. If we look at B down here, we have a situation of a diameter that's perpendicular to a chord. If it's perpendicular to a chord, then it means that it splits the chord into half. So the distance from here to here, from H to K, is going to be twice that of N to K, which is 7. It also splits the arc into two parts. So that means that H to J is going to be equal to J to K. And you just set these two equal to each other to solve. Now, does the measure of the arc angle HL equal to JK? Are those angles, those arc angles, the same? And why or why not? Well, you can pause and think about this. In looking at JK and HL, you'll notice that the angle does not come from the center. So it's not the central angle. It's coming from some other chords that are inside of the circle. So it's not going to be the same. They're not equal. So if you measure that, that is not going to be the same thing as HL. And that's because they're not central angles. Now the vertical angles are going to be the same. That's going to be true, but not the arc angles. So be careful. Here's another theorem, the equidistant chords theorem. This says that in a circle, two chords are congruent if and only if they are equidistant from the center. So if I have chords that are congruent, then they will be equidistant. And we're talking about a perpendicular distance from the center. If we have chords that are equidistant from the center, then the chords themselves must be equal to each other. So this is a biconditional. And in this problem, you can see that we have a diameter that's perpendicular to a chord. And we know through that one theorem that it splits this chord perfectly in half, and it also splits the arcs. Since QR is equal to ST, they're congruent, then that means that they're equidistant from the center. So this is equal to this. 2x is equal to 5x minus 9, and you can solve for these parts. As far as the radius of the circle, well, the radius of the circle is going to be from C to any point on the circle. And I will leave it to you to decide if you can calculate the radius of the circle. In this last problem, we're given that AB is perpendicular to CD. And AB and CD, since they're perpendicular, then we have a right triangle here. That's nice. Maybe we can use that. Notice that the radius starts from A and goes all the way out to B. That's distance of 4 plus 2, which is 6. So that means that the distance from A to D is also going to be 6. Once I have the distance 6 here and 4 here, and this is a right triangle, I can come up with this distance here from D to the intersection. And once you have that, you know that this being perpendicular to this chord, then it splits this chord perfectly in half. Therefore, whatever distance that you get for this, you just multiply times 2 to get the total distance from C to D. And I'll let you calculate that on your own. We'll discuss more of this in the next class.